Hey everybody, Mr. Conan here, and today I've been getting a lot of questions about the different forms of a quadratic function. So today I'm going to talk about what makes standard form special, what makes vertex form special, and of course what makes factored form special. First things first, standard form. We write standard form as f of x is equal to a times x squared plus b times x plus c, where a is the coefficient of the quadratic term, b is the coefficient of the linear term, and c is the constant term. So we've seen these words quadratic, linear, and constant in the past when talking about polynomials. Basically, just a little Spark Notes version, a is the number in front of x squared, the quadratic term, b is the number in front of x, the linear term, and c is the constant all off on its own. Now with standard form, the special bit of information that it gives us is the y-intercept. C will always be the y-intercept of your function. If you ever need to graph a standard form quadratic, we automatically know, if it's given in standard form, where it crosses the y-axis. Let's talk about vertex form. Now this is written a little bit differently than standard form. We have y is equal to a times x minus h squared plus k. Now, the reason why I colored the a the same color as the last one is, it's the same value. The a for a standard form quadratic will be the same a for a vertex form quadratic. A is the same as standard form. H is the x coordinate of our vertex, or what we know as the axis of symmetry, or AOS. K is the y coordinate of the vertex. Now I want you guys to notice here, in vertex form, it is x minus h. When we pull that out into our vertex, it's going to be written as hk. So, whenever we write the vertex of a quadratic given vertex form, we switch the sign in front of h when writing it as a point. We do not switch the sign for k. Factored form is written as f of x is equal to a times x plus p times x plus q. Again, that red a means it's the same exact value as before for the past two forms. Now with this p and q, these are new letters. B is equal to p plus q, and c is equal to p times q. As we talked in class, if we ever want to factor a quadratic function, we have to find two numbers that multiply together to get c, and add up together to get b. Now factored form helps us find the solutions, or the x-intercept. If I have a quadratic in factored form, it's a lot easier to find out where we cross the x-axis, or what x values make the y value equal 0 for that function. And I'll show you guys once we start looking at the graphs why. Now all three forms can be used to represent the same function. In this example, I'm bringing up the standard form equation f of x is equal to x squared plus 8x plus 12. This is the same thing as saying f of x is equal to x plus 4 squared minus 4 for vertex form, or x plus 6 times x plus 2 for factored form. All three of these equations are the exact same, just written differently. Now we're going to take a look at the graphical representation of these functions and understand exactly what bits of information we get from each one. Now I want to preface this by saying, if you plug an x value into any of these functions, you will get the same y value out. But the little bit of information that we're given at the beginning is different for each of these functions. So with standard form, for f of x is equal to x squared plus 8x plus 12, this is what that quadratic looks like. What we're given from this quadratic is that 12 there. I know it's off the graph. I'm sorry I picked an example that wasn't on the grid, but when we plug 0 into the function for x, we get 12 out. So that's why I have that little green dot up there. Hopefully that makes sense. It gives us the y-intercept. For vertex form, I have f of x is equal to x plus 4 squared minus 4. Now vertex form, mathematicians really aren't the greatest at coming up with names for things. That's obviously here. It gives us the vertex. Now, in this case, the vertex, the middle point, the maximum or minimum, the turning point for our quadratic is negative 4, 4. And we actually get that from our equation. We get the x value from that plus 4 on the inside, dealing with the x value. We switch the sign for that value because for the original vertex form, it's x minus h. In this case, since we have a plus there, when we pull that out, it's going to be a negative. For the y value, we get it from the minus 4. I wrote that wrong. I apologize. Let me fix that real quick. Boom, negative 4. So our vertex would be at negative 4. Negative 4. Now with factored form gives us the x-intercepts for our function. Here, if I have x plus 6 times x plus 2 and I want to find the x-intercepts, that means I'm looking for the x value that's going to make it equal 0. So I'm going to set both of these little equations up are equal to 0 because of a little thing we have called the zero product property. Basically, that means if the whole function's equal to 0, if I want to find the x value that makes the whole function equal 0, that means that one of these two things, or both of them that I'm multiplying together, must also equal 0. So I have x plus 6 equals 0, and I have x plus 2 equals 0. Well, here's the thing. Only value that's going to make that equal 0 on the left is negative 6, and on the right is negative 2. If you look at your graph here, what do you know? We have points where we cross the x-axis at negative 6 and negative 2. All of these different forms of quadratic give us different information, but we're really talking about the same thing. I hope this was helpful for you guys. Again, please, 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 while we're doing this distance learning, send me emails asking me questions, or if you have an idea for a video, let me know. I'm going to try to put out at least a video a day or so, just so that you guys can stay on top of all this. Thank you for watching. I hope this was helpful. And if I can ever learn how to stop this video, give me a second here. Boop, boop, doop, doop.